Hello there, and welcome to the Sleepy Science Drift. Tonight we'll drift quietly into the heart of darkness, where gravity bends light and time, and silence becomes the only sound. Imagine yourself floating in the black sea between the stars. The engines are off. There is no up or down, only the faint shimmer of distant suns and the slow pull of something unseen ahead. You are falling, but it feels like resting. Somewhere in the distance, a giant waits, a supermassive black hole, the heaviest object in the known universe, a silent heart that has swallowed millions of stars. You might expect fear. You have heard the stories, the warnings about spaghettification, about being stretched thin like a thread until you cease to be. Yet, as the pull deepens, something in you quiets. The darkness is not violent. It does not roar or chase. It simply accepts. And in that acceptance, there is peace. Let us stay here for a moment and listen to what gravity is saying. Gravity does not speak in words, but in curves, in motion, in stillness. Every star, every planet, every breath you take is written in its language. Newton once called it the universal law, but that law feels less like command and more like rhythm. The universe hums with its pulse. Two masses meet. They lean toward each other. They dance. The larger leads, the smaller follows. It is not a war, but a slow embrace. If you could see gravity, you would not see chains or hooks. You would see threads of space itself bending softly, like fabric folding under a drop of rain. You would see galaxies spiraling inward, not out of destruction, but out of longing. In this cosmic choreography, nothing truly collides. It converges, it surrenders. Now imagine two small stones drifting near each other. They are drawn together by an invisible line. Double the distance, and that line grows weaker by 4. Triple it, and it weakens by 9. That is the quiet symmetry of the inverse square law. Gravity, like compassion, fades gently with distance, but never disappears. It is infinite in reach, even if its touch grows softer. As you drift closer to the black hole, the pull becomes uneven. Your head feels a little less tugged than your feet. Your body, stretched between two whispers of the same force, begins to sense the difference. This is what physicists call a tidal force. It is not about how strong gravity is, but how it changes from one point to another. It measures the slope of attraction, the curve of space that runs across your length. On Earth, this difference is tiny. Too small to notice. You do not feel your head lifted or your feet pressed harder. But near something vast, that gradient sharpens. The universe, once smooth, begins to show its folds. To visualize it, imagine a ring of small stars orbiting a giant one. The side facing the giant feels a stronger pull, while the far side drifts slightly behind. Over time, the ring stretches into an oval. Along one direction, it lengthens. Across another, it squeezes. The balance shifts, not violently, but inevitably. That is the whisper of the tides. You have seen this before, even if you did not name it. The oceans rise and fall beneath the moon's soft pull. Twice each day, water climbs the shore and retreats again. The same math that shapes galaxies is hidden in the rhythm of waves brushing sand. The Earth itself swells ever so slightly, breathing to the lunar song. And somewhere within that same gentle tension, the black hole breathes too. Let us return to you, falling through the dark. The stars behind you fade, swallowed by the curvature of light. Time slows, as if holding its breath. The black hole grows, not because it moves, but because space itself folds toward it. You cross invisible thresholds, layers of gravity denser than air, denser than thought. Yet there is no sensation of speed, only descent. The event horizon, the edge of no return, still lies ahead, but the pull you feel now is not cruel. It is calm. If you could step outside yourself, you would see how space bends differently at your head and at your feet. Those two ends of you no longer fall quite together. The difference is small, like the difference between two notes in a distant song, but it is real. Physicists write this as an equation. Delta F equals 2 gmm over r cubed times delta r. It looks harsh in symbols, but what it says is simple. The closer you are, the sharper the difference. The longer you are, the more you feel it. And when the distance to the center becomes very small, the gradient becomes steep enough to break you apart. But not here, not yet. Because this is not a small black hole. This one, the supermassive kind, is gentle. Its pull changes slowly across your body. You could cross its horizon without knowing. The silence around you would deepen, but your body would remain whole. You would not be torn or stretched. You would drift through the gate of infinity as quietly as mist slipping over a mirror. Why is that? Why does something so enormous, so absolute, treat you with such tenderness? The reason lies in scale. The stronger the overall gravity, the wider its reach and the smoother its gradient near the edge. The smaller the black hole, the steeper its curve, the sharper its grip. A stellar mass black hole, a tiny one born from a collapsed star, has a horizon only a few kilometers wide. There, gravity changes violently over the space of your body. But a supermassive black hole's horizon can span billions of kilometers. Its field, spread across that vastness, feels almost flat. It is as if the universe itself knows moderation. Where it grows vast, it grows soft. Where it shrinks, it grows fierce. The small devour, the great absorb, and yet both obey the same quiet mathematics. If you were to map this, you would see a gradient of calm. Near Earth, gravity pulls but barely changes. Near the sun, it presses harder but remains even. Near a white dwarf, it begins to bite. Near a black hole, the bite becomes a tear. Yet as the black hole grows, the tear becomes once again a touch. In every case, the law is the same. Gravity is not cruel, only consistent. It bends space, and space bends us. Here, floating before the edge, you begin to sense another truth. The universe does not distinguish between falling and orbiting, between rising and resting. Everything moves in curves. Your fall is not a failure. It is a continuation. Even light bends toward what it loves. Think of how the night sky looks from Earth, each star shining alone, each beam crossing space for thousands of years. Some of those photons may never reach another world. They wander, patient and pure, until they meet a horizon. There, they vanish, not in violence, but in return. For a black hole is not a hole in the sense of absence, it is a boundary of belonging. Once you cross it, you are no longer separate. You become part of the geometry that holds galaxies together. Stephen Hawking once wrote that black holes are not eternal prisons, but temporary states, releasing their energy in whispers of radiation. Even these cosmic graves decay into light. In time, everything the universe hides, it will reveal again. Perhaps that is the quietest promise of all. So as you drift closer, you might wonder what safety means in a place where nothing escapes. To be safe does not always mean to be free. Sometimes safety is simply surrender. The black hole does not protect you from falling. It gives you a place to fall into. It is the final form of gravity's compassion, a curve so deep it ends all motion, yet holds everything within it. You look around. There is no horizon visible, no bright line marking where space ends. Only a slow dimming, as if the stars themselves are bowing out of sight. Your body floats steady. Your heartbeat slows. Time itself feels thick, syrupy, almost still. You can no longer tell if seconds pass or stretch. You remember that time and space are not separate here. They are woven into one fabric, and that fabric is folding. You think of the earth, still turning somewhere far away, tides rising and falling in their endless rhythm. You think of the moon, gentle and distant, pulling at oceans. You think of how every movement, from a leaf's fall to a planet's orbit, follows the same invisible grace. Gravity is not a monster hiding in the dark. It is the pattern by which the universe breathes. The closer you come, the more you feel the hum. Not a sound, but a pulse, deep and low. Perhaps it is your heart. Perhaps it is the curvature of space itself. You realize that to understand gravity is to understand connection. Everything draws everything else. Every atom pulls every other. You are not falling alone. The stars fall with you. The galaxies fall with you. The universe itself, expanding yet bound, is one great fall toward itself. And as this thought settles, fear dissolves. The dark ahead is not an enemy, but a mirror. It shows you what has always been true, that all motion ends in stillness, and all stillness begins with motion. The black hole is simply the quietest place in the cosmos, where every force finds rest. So you close your eyes. You let go of distance, of weight, of sound. You are not moving anymore. You are being moved. Space is carrying you, gently, into its center. There is no edge, no crash, no scream. Only the slow breath of creation folding inward. And somewhere within that breath, you realize the paradox that began this journey. The mightiest objects in the universe are not the most violent, but the most serene. The supermassive black holes, with their billions of suns worth of weight, do not tear apart. They cradle. They are not the monsters of nightmares, but the sleeping giants of reality, their silence deeper than any fear. The stars drift slowly, the galaxy breathes, and within that breath, you rest. Imagine now that we linger within the quiet pull of space, watching how gravity reveals its subtleties. What we often call force is not always strength. Sometimes it is difference. The universe does not only pull, it stretches unevenly. That unevenness, soft yet absolute, is what we call a tidal force. It is the reason the seas rise and fall on Earth, and the reason a body drifts apart when it strays too close to a compact star. It is not the violence of gravity that shapes the cosmos, but its variations. Like the rise and fall of breath, gravity's change creates motion, and motion becomes form. Picture a simple moment on Earth. The ocean rests beneath a full moon. In the dark, the water shifts almost imperceptibly. On one side of the planet, the sea climbs the shore. On the opposite side, it does the same. Between those bulges, the beaches stretch wide and dry. Every 12 hours, the ocean reshapes itself under a pull you cannot feel, yet one strong enough to move entire continents of water. The reason lies not in the moon's strength alone, but in the small difference between its pull on one side of Earth and its pull on the other. That difference, delicate as a sigh, lifts oceans. In the language of physics, a tidal force is the gradient of gravity. It measures how the pull changes from point to point. You can imagine it as a slope on a vast invisible field. The steeper the slope, the greater the difference, the stronger the tide. The moon's gravity at the near side of Earth is just a little stronger than at the far side. That small disparity becomes a global rhythm. The same pattern exists everywhere, from the surface of the sea to the heart of a galaxy. If you drew two dots in space, one slightly closer to a star than the other, each would feel gravity differently. The nearer dot would fall faster. The farther one would lag behind. Over time, the pair would stretch apart, a silent elongation written in distance. Now imagine millions of such dots forming a sphere. The side facing the star would bulge outward. The sides perpendicular would compress inward. This is the cosmic breathing of matter, a slow dance between stretch and squeeze. It happens around planets, around stars, and around black holes. Every object, no matter how small, is part of this tidal conversation. Let us think of your own body as a miniature planet. When you stand on Earth, your feet are slightly closer to the center of gravity than your head. The pull on your feet is infinitesimally stronger. The difference is so tiny that it vanishes in noise. Yet mathematically, it exists. If you could measure it, you would find the pull on your head weaker by a fraction so small that it feels like nothing. That nothing is the same principle that moves oceans and bends moons. On Earth, this gradient is mild. The numbers tell us that the tidal difference across a human height is about 6/10,000ths of a Newton. Such a force is invisible, quieter than a heartbeat. But near denser bodies, where distance shrinks and curvature deepens, that same principle awakens. It is as if gravity, once a calm lake, becomes a waterfall. The slope grows steeper, the flow faster. A body caught in it is no longer held together by its own structure. The pull across its length becomes too uneven, and the bonds that tie it begin to unravel. In the soft way that nature teaches, every violent idea is born from a gentle one magnified. The tides that rock the ocean are kin to the forces that tear stars apart. The difference is scale. Between these scales lies the story of the universe's patience. Gravity changes slowly across vast distances, but as matter compresses, as stars collapse into smaller radii, that change grows abrupt. The same equations that cradle the Earth also govern the destruction of suns. If you could see this as a picture, it would look like a network of invisible threads, each line bending differently with distance. Near a massive body, the lines curve sharply together, crowding like rivers near a whirlpool. Farther out, they flow nearly parallel, calm and ordered. The tidal force is simply the measure of how tightly those lines curve. In one place, they form a gentle gradient, in another, a fierce drop. The beauty of this lies not in the math, but in the pattern. Every pull has its counterpull. Where one side stretches, another compresses. This balance creates the sculpting power that shapes galaxies. When a star strays near a black hole, the side closer to the hole feels more gravity and falls faster. The far side lags behind. The star elongates, becomes a stream, then a ring of fire. The same tension that lifts tides on Earth shreds suns across the void. Yet even that destruction has elegance. The stream of gas spirals inward, glowing with the light of friction, painting the darkness with arcs of energy. Tidal forces are not only a lesson in physics, but a mirror of existence. They remind us that difference creates motion. Without variation, there is no life, no rhythm, no orbit. If gravity were perfectly uniform, nothing would change. Planets would not circle, oceans would not breathe. It is the uneven pull, the delicate imbalance, that makes everything move. Life itself depends on such gradients of heat, of pressure, of energy. In the smallest cell and the largest galaxy, it is difference that drives being. When Newton first described the law of gravity, he wrote of a single attraction that connects all masses, but he could not yet see the curve beneath the force, the way Einstein later would. According to general relativity, tidal forces are not truly forces at all, but geometry. They arise because space itself bends differently from point to point. Each path of fall is a line in that curved space. When 2 points begin close and follow nearby lines, those lines either converge or diverge. The result feels like a stretch or a squeeze. Yet, in reality, both are just the natural shape of space-time itself. If you float freely in space, far from all masses, you feel weightless. If you drift toward a planet, you accelerate, but you still feel no pull as long as every part of you accelerates equally. Only when different parts move at different rates do you feel stress. That is what gravity's gradient does. It introduces difference. It transforms smooth motion into tension. Think again of water rising on Earth. As the moon circles above, the oceans do not chase it like a pet. They respond to the difference in pull between the near and far sides. The same occurs with the sun, whose tidal effect is about half that of the moon, despite its enormous mass. Distance softens intensity. Power spreads thinly across vastness. If the moon were closer, tides would swell higher. If it were smaller or farther, the oceans would quiet. In each case, the rule is the same. The strength of the tide falls rapidly with distance, as 1 over the cube of the separation. Double the distance, and the effect drops 8-fold. Such sensitivity reveals the fragility of balance in the universe. Everything depends not just on how much mass exists, but where it is and how space carries its influence. Now imagine extending this principle to cosmic scales. A star orbiting near a black hole feels the same rule. Its near side pulled harder, its far side eased. For small black holes, the change across the star's diameter is immense, enough to rip it apart. For supermassive black holes, the change is so slight that entire planets could cross the horizon unbroken. This is the paradox of gravity's compassion. The larger the being, the gentler its touch. If you were to watch a simulation of tides around a star, you would see patterns like breathing. Rings of matter expand and contract, shaping waves of density that travel outward. Each wave carries information about the gradient that formed it. In this way, gravity not only pulls, but also communicates. Its language is curvature. Its alphabet is motion. When you look at the night sky, the concept becomes poetry. The Milky Way stretches in a soft band because countless stars orbit under the combined gradient of their mutual attraction. The spiral arms form where those gradients compress gas, triggering birth after birth of new suns. Even our solar system is a product of tidal harmony. The planets settled into their orbits as the early sun's rotation spread material outward, balancing inward pull and outward motion until stillness emerged within motion. The Earth itself, spinning and breathing, feels the moon's slow drag. Over eons, that drag transfers energy, pushing the moon farther away. Every year, it retreats by about 4 centimeters. A tiny movement, but one that reshapes the length of our days. 1 billion years ago, the moon hung closer, and the tides surged stronger. The dance has softened with time, a quiet aging of a cosmic partnership. Through all of this, the universe whispers a lesson. That change, when stretched over enough time, becomes peace. The oceans do not rage at the moon, they follow. The moon does not resist the earth, it drifts. This obedience to difference, this surrender to gradual pull, is the reason everything remains in motion without chaos. In your own life, you may feel tides of another kind. Emotional gravity, moments when you are pulled more strongly one way than another. The same principle holds. What tears us is often not the strength of what draws us, but the suddenness of change. Gentle gradients create rhythm, abrupt ones create rupture. A black hole that is too small destroys. One that is vast allows passage. In human terms, patience is the supermassive version of love. It holds without breaking. Physics and philosophy meet here, where equations describe empathy. The universe is not a machine of cruelty. It is a field of balance where everything adjusts to everything else. The tidal forces that sculpt galaxies also smooth them. Over time, even violent interactions settle into symmetry. A collision between galaxies looks catastrophic, but when the stars pass through, few ever collide. Gravity rearranges them into new spirals, new calm. If we could step back and see all of this at once, we might understand that the universe has no intention of harm. It simply follows curvature. Where the slope is gentle, we orbit. Where the slope is steep, we fall. But every fall is just another curve in a larger calm. Even the black hole, often imagined as destruction, is a continuation of the same principle that lifts our tides. So next time you watch the ocean breathe, remember that it is the same breath the cosmos takes. Each wave is a whisper of geometry. Each shimmer on the water's edge is a hint of the invisible slope that binds galaxies. The moon above you, pale and distant, is not just a companion, it is a teacher of balance. It reminds you that power does not need violence, that difference can create rhythm, and that motion, when sustained with grace, becomes harmony. In this understanding, tidal forces become more than equations. They become a meditation on connection. Every variation of pull, every tiny gradient is a thread in the fabric of being. The universe stretches and squeezes not to destroy, but to evolve. And just as the tide returns to shore, everything that drifts away will one day come back, reshaped, quieter, but still part of the same endless sea. Imagine for a moment that you are standing quietly on the surface of the earth. You feel solid ground beneath your feet, the soft weight of your body, and the gentle pressure of air against your skin. Yet hidden beneath all of that calmness is a field of gravity stretching from the core of the planet out into the infinite dark. It holds the oceans in their basins, the mountains in their roots, and the atmosphere around the world like a soft blanket. It also holds you. Every atom of your body feels this downward pull, a connection to the Earth's heart. You are part of the same quiet conversation of matter and space. Now imagine measuring the pull on your head and then on your feet. The difference is nearly nothing, less than a whisper of force. Physics gives it a number, a fraction of a Newton so small that no muscle could feel it. You could stand 1,000 lifetimes and never sense the stretch. Yet that invisible difference is real. It is the same tidal gradient that shapes the sea, only softened by distance and scale. It is the reminder that even here, in safety, you live within the same laws that rule the stars. This subtle force tells a larger story. Gravity is everywhere, but its intensity changes with size and distance. The Earth's mass creates a gravitational field that pulls you downward, but because the planet's radius is so large compared to your height, the difference between your head and feet is tiny. The gradient is gentle, almost flat. You live in a calm valley of gravity, and so life is possible. Plants grow upward, rivers flow, hearts beat evenly. Let us travel now in imagination to the sun, that blazing sphere of plasma 93 million miles away. Its gravity is vastly stronger than Earth's, 28 times greater at its surface. If you could stand there, which you cannot, your weight would crush you instantly. But if you could somehow endure the heat and pressure, you would notice something curious. The difference in gravitational pull between your head and your feet would still be smaller than on Earth. The sun's body is enormous, 700,000 kilometers in radius. Its gravitational slope is smooth. Its power is vast but distributed gently. The gradient across your body would be less steep, and the tidal force would feel even smaller. This truth hides a quiet paradox. The greater the body, the softer its local pull. The sun's gravity is stronger overall, yet its change across small distances is weaker. Its mass is immense, but its surface is far from its center. The curvature of space around it bends slowly. That is why the sun, in all its ferocity, is a gentle giant in the language of tides. It holds the planets in their orbits, not by violence, but by patience. Think of the planets circling it, each moving at its own pace, each held by the same invisible thread. Mercury, quick and restless, traces tight loops. Neptune, distant and calm, drifts through centuries. Yet none of them escape. None are torn apart. The sun's gravity changes gradually enough that each world moves in harmony. If the sun were smaller, with the same mass compressed into a tighter space, those orbits would twist and break. But because the sun is large, it rules with steadiness. Power combined with calmness becomes balance. Let us look deeper into what these numbers mean. The sun's surface gravity may be fierce, but its tidal pull across a human body would be about 1/100th of what you feel on Earth. That difference reveals something profound. Intensity and sharpness are not the same. A force can be mighty and yet smooth. The same principle holds in life. Strength does not need aggression. The sun burns with unimaginable heat, yet its influence across small distances is tender. Now let us explore how this relationship evolves as we change size and density. Suppose we keep the sun's mass the same, but begin to shrink its radius. The gravitational gradient grows steeper as the surface moves closer to the center. The same total mass packed into smaller space means that each step inward increases the pull dramatically. The difference in force between your head and your feet would grow 8-fold each time the radius halves. This relationship is precise. The tidal force depends on 1 over the cube of the distance. That small exponent hides vast consequences. Half the distance, 8 times the change. 1/4 the distance, 64 times the stretch. As stars collapse, the slope of space sharpens like a blade. The smooth valley becomes a cliff. When the same mass that once glowed peacefully as a sun compresses into a white dwarf, the gradient becomes hundreds of times stronger. A person standing near such a star would feel a pull difference across the body large enough to notice, perhaps even to harm. Yet there is still beauty in this mathematics. It tells us that violence is simply curvature accelerating toward its limit. To understand why, think of the space around you as a vast fabric. The Earth makes a shallow dip, a bowl you can walk upon without falling in. The Sun makes a deeper one, wide and round. A white dwarf, though, creates a steep funnel, narrow and sharp. The smaller the radius, the faster the slope rises near the edge. This shape of space dictates the destiny of everything near it. Where curvature is gentle, orbits are stable. Where it grows steep, matter begins to fall inward without return. In a quiet sense, this is also a story about how the universe balances intensity and tenderness. The same force that lifts tides and shapes galaxies grows fierce only when it loses space to spread within. As stars shrink, gravity concentrates. What was once the breath of a sphere becomes the whisper of a point. The mathematics stays constant, but the feeling changes. The sun warms, a white dwarf warns. Let us bring this closer to human scale again. Imagine yourself floating just above a white dwarf's surface. It has nearly the sun's mass, but is no larger than Earth. Its pull is crushing. You would weigh hundreds of thousands of times more than on Earth. And the difference in pull from head to foot would be no longer negligible. Each step downward would feel like walking into a storm of invisible hands. The tidal force could tear molecules apart, not in rage, but through inevitability. The space around you would not be hostile by choice. It would simply be too curved for your body to hold itself together. In that thought lies the tenderness of truth. The universe does not intend harm. It only follows geometry. The same equation that allows planets to dance also allows matter to collapse. Nature has no preference between creation and destruction. Both are movements within the same curve. From this perspective, every form of life exists within a narrow corridor of moderation. On Earth, gravity's gradient is mild enough for bodies to remain whole, for oceans to stay calm, for hearts to beat without tearing. If the planet were smaller but just as massive, its tides would be deadly. If it were larger and lighter, the air would drift away. Our world is tuned by this delicate slope, balanced between pull and peace. There is a quiet lesson here about scale. The same laws apply everywhere, but their effects depend on proportion. What saves us is not exemption, but position. We live at the right distance from the right mass, inside the right gradient of force. Our survival is a matter of slope. In a sense, existence itself is a balancing act on the gentlest part of gravity's curve. When scientists describe these differences in numbers, it can sound cold. 2 times 10 to the negative 4 newtons here, 1,000 there. But behind those digits lies something spiritual. Each value represents how sharply the universe changes from one point to another. Each number measures not just power, but contrast. It is the same kind of contrast that defines beauty, music, or thought. A song without change has no melody. A world without gradient has no motion. The universe composes itself through variation. You can feel that when you look at the sky at night. The stars appear still, but they are moving, responding to subtle curves in space. Their positions trace invisible equations across time. Even light, that fastest of travelers, bends as it passes near mass. It follows the geometry of existence without resistance. To a photon, the path of least energy is not a line, but a curve. Gravity does not force it. Space itself guides it. This gentle surrender of motion to curvature is what defines cosmic harmony. When an astronaut drifts in orbit, they are not escaping Earth's gravity. They are falling around it, forever missing the ground. Their path is a compromise between pull and motion, between descent and flight. The body in orbit feels no weight because every part of it falls equally. Only difference creates tension. Only unevenness produces feeling. The human experience mirrors this. When our thoughts and emotions fall together, we feel peace. When parts of us move at different speeds, we feel strain. The body resists the gradient within. Physics and philosophy align here. Equilibrium is unity of motion, and stress is divergence. A tidal force inside the soul feels like longing. It is the difference between where we are pulled and where we wish to remain. Perhaps that is why the study of gravity feels so intimate. To understand why we stand firm or fall apart is to understand how connection works. Every relationship, every orbit depends on distance, on change, on proportion. Too close and we dissolve. Too far and we drift away. Somewhere in between lies balance. The earth and sun have found it. The moon and ocean have found it. Even you, standing still, are part of it. In this way, science becomes meditation. Each calculation reveals not control, but belonging. The tidal difference across your body may be small, but it ties you to the curvature of the planet, to the mass of the sun, to the spiral of the galaxy. You are stretched gently by the same geometry that bends starlight. When you move, the universe moves with you, infinitesimally but truly. So the next time you feel the solid ground and the quiet sky above, remember that both are part of one field. Between your head and your feet flows the smallest gradient of gravity, and through that gradient runs the same pattern that sculpts black holes. You stand in the calm center of cosmic design, where the slope is kind and the forces balanced. Far away, in regions where mass collapses into itself, the difference becomes too sharp. There, matter yields to geometry completely, turning into energy, then into light, then back into silence. But here, in this fragile zone of moderation, gravity is soft enough to let life bloom. Every blade of grass, every wave, every heartbeat is an echo of that softness. The lesson is simple and infinite. Strength without balance destroys. Balance without strength dissolves. The universe survives because it is both. Gravity teaches that to hold gently is not weakness, it is mastery. The sun could crush the earth in an instant, but it does not. It holds instead, giving warmth and orbit, allowing space for existence. In that patience lies the secret of stability, the calm intelligence of the cosmos. And so, as you imagine yourself standing again, head beneath sky, feet upon stone, know that the same equations that describe the pull of stars also describe the peace within you. You are the geometry made conscious, the curve that knows it curves. The universe stretches and you stretch with it, not in pain, but in rhythm. And somewhere, far beyond sight, another star is learning the same lesson, that every gradient, every pull, every fall is part of the same quiet symmetry that holds everything together. Imagine the sun, vast and glowing, suspended in the quiet dark. It burns with the memory of hydrogen and the promise of light. For billions of years, it has been the anchor of our solar system, a steady rhythm in an otherwise restless sky. Yet even the sun will one day cool. Its fuel will fade, its balance will tremble, and gravity will take command. Slowly, over eons, the star will collapse inward. The warmth that once held the planets will fold into silence. What remains will not vanish, but transform. The sun will become a white dwarf, a pearl of gravity shining softly in the dark. A white dwarf is the afterthought of a star, the quiet echo of fusion. It holds almost the same mass as the sun, but compresses that mass into a sphere no larger than Earth. The pressure inside it is unimaginable. The atoms packed so tightly that electrons push against the laws of proximity. It is a body defined not by fire, but by density. From far away, it looks calm, a small light drifting among the ashes of its past. Yet the space around it is steep, curved sharply by its compactness. Gravity here is not loud but absolute. If you could stand near a white dwarf, you would feel its presence before you saw it. The pull would be immense, the air, if any remained, thick with potential. You would weigh hundreds of thousands of times more than on Earth. But what is more astonishing is how quickly that pull would change across your own body. The difference between the gravity at your feet and the gravity at your head would no longer be subtle. It would be fierce enough to lift you apart from yourself. The same soft gradient that raises Earth's tides would become a blade of force, cutting through the fragile cohesion of matter. Yet even this destruction is graceful. It follows a rule, simple and universal. Tidal force grows with density, with closeness, with concentration. When mass gathers into smaller and smaller spaces, its pull becomes uneven, and that unevenness becomes motion. The universe, it seems, creates its own drama by folding on itself. The same equation that keeps planets in orbit also dictates the end of stars. In this symmetry, there is no cruelty, only completion. Let us imagine shrinking the sun step by step. Halve its radius, and the tidal force on your body increases eightfold. Halve it again, and the gradient multiplies by another 8. As the sphere becomes smaller, its gravity becomes sharper, the curve of space-time tighter. Eventually, the pressure grows too great for ordinary matter to resist. Atoms surrender their separateness. The space inside them collapses until the nuclei themselves begin to touch. This is the birth of the white dwarf, a crystal of matter so compact that a single teaspoon would weigh as much as a mountain. To stand before such an object, even in imagination, is to feel the intimacy of power. You would not hear it roar. There is no sound in the vacuum, and even if there were, a white dwarf would whisper rather than shout. Its energy is ancient, its fury long spent. It glows with the slow cooling of time. Its light is the ghost of what once was, the memory of a star's beating heart preserved in a smaller, denser shell. The space around it is the same space you know, yet curved differently, as if reality itself leans toward it with reverence. Here, gravity begins to reveal its true nature. It is not a force in the way we once thought, but a shape, a bending of the fabric that holds everything. Einstein showed us that mass tells space how to curve, and space tells mass how to move. Around a white dwarf, that curvature tightens into a funnel. Any object that drifts near it feels the steepness, the change from smooth descent to sudden drop. To the falling particle, there is no sensation of speed, only the inevitable approach of the center. If a planet were to wander too close to this dense star, it would begin to unravel. Its near side would feel a stronger pull than its far side. The rock and gas would stretch, forming a stream that spirals toward the white dwarf like smoke into a flame. This process, so gentle on cosmic timescales, would appear almost serene if sped up. The planet would not explode but dissolve, its pieces joining the ring of material orbiting the dwarf. Over time, that ring would glow, a faint halo of remembrance. The dead star would feed quietly on the remains of its companion. There is poetry in this cycle of compression. The same gravity that once held the star together through balance now compresses it into stillness. The pressure of life becomes the silence of endurance. Even in collapse, order persists. White dwarfs do not vanish. They linger, cooling for trillions of years. Their light fades, but their mass remains, locked in a perfect pause between motion and oblivion. This moment between being and not being carries deep meaning. It shows us that the universe does not rush. Death, in cosmic terms, is never sudden. It is a continuation, a change of rhythm. The sun's collapse into a white dwarf will not be an explosion, but a gradual sigh. Its outer layers will drift away into space, forming delicate shells of gas, glowing like lanterns for a brief cosmic season. The core that remains will shrink quietly, glowing with residual heat. And long after Earth and its memories are gone, that white dwarf will still exist, a pearl of gravity shining faintly in the galactic sea. The tidal forces near such a remnant are immense but predictable. They follow a logic that has no mercy and yet no malice. Imagine holding a chain between your hands. The tension increases as you pull, and when the links break, they do so not out of anger, but because the metal reaches its limit. The same is true of matter near a dense star. The molecules stretch until their bonds cannot hold, and then they part. The universe breaks things only when it must. To think of this process is to reflect on the balance between strength and surrender. The sun resists gravity through fusion, through heat that pushes outward. When the fuel ends, that resistance fades and gravity wins. But in that victory, there is no cruelty. It is the return of the star to its natural shape, the curve it has always leaned toward. We might see collapse as loss, yet in the language of the cosmos, it is release. Every collapse in nature follows this same principle. A leaf falling from a tree, a wave retreating from the shore, a star shrinking into a dwarf. All are acts of balance restored. The leaf does not fight the air, it joins it. The wave does not battle the sand, it merges with it. The star does not flee gravity, it becomes gravity. And in each act, something quiet and complete takes form. If we look further still, beyond the white dwarf stage, we reach the threshold where density surpasses even this limit. When the pressure of electrons can no longer withstand the weight of collapse, the matter falls deeper into a neutron star, and beyond that, into a black hole. Yet each stage follows the same gentle curve, the same logic of compression and surrender. The path from shining star to silent void is not a fall from grace, but an evolution of it. To understand this is to find peace in impermanence. The universe is full of endings, but each ending is another form of continuation. The white dwarf, though small, carries within it the memory of every fusion reaction that ever burned in its heart. It holds the history of the light that once warmed worlds. Its gravity may be fierce, but its purpose is pure. It is the seed of new beginnings. Scientists have calculated that over trillions of years, even white dwarfs will cool into black dwarfs, invisible to the eye. Their heat will radiate away until only their gravity remains, silent and cold. In that final state, they will still curve space, still hold matter, still participate in the quiet fabric of existence. They will not die, they will simply fade from view, resting in the same cosmic calm that birthed them. When you think about this transformation, it begins to resemble a meditation. The universe breathes in and out through creation and collapse. Stars ignite and fade. Galaxies spin and slow. Every motion is part of a larger stillness. The sun's death is not tragedy, but rhythm. One day, the Earth will no longer orbit, the planets will drift, and the solar system will dissolve. But somewhere within that dissolution, a single white star will continue to glow, carrying forward the light that once gave us life. If you were to drift close to such a star in some far future, you might feel awe rather than fear. The light would be soft, the pull immense. You would sense the past folded into every atom. The gravity that could tear you apart would also be the same gravity that once held a solar system in balance. It would feel like touching the edge of eternity. And yet, even as we imagine this, the thought brings peace. Because the universe does not end in chaos, it ends in structure. Every stage of collapse creates a new harmony. The white dwarf is not a wound, but a scar that has healed in its own way. It is the universe remembering itself through stillness. In that realization lies a deeper truth. All things that burn must eventually cool. All things that resist must eventually yield. And all things that fall must eventually rest. Gravity does not destroy meaning, it transforms it. The white dwarf, dense and silent, is proof that even after the brightest fire fades, something enduring remains. It is the universe's way of whispering that nothing truly vanishes. So let us drift there in thought, beside that small, heavy star. Let us imagine its slow rotation, its faint blue glow, the way its gravity shapes the space around it into invisible waves. If you close your eyes, you might almost hear it hum, not in sound, but in certainty. The hum says this: everything changes, but the pattern endures. Every collapse is an act of continuation. Every darkness hides a quiet light. The stars die, as we all do, but not in despair. They die into form, into peace, into the deeper stillness from which they were born. And as the last light of the white dwarf fades into the endless night, it leaves behind the same truth that has guided the cosmos since the beginning, that even the most powerful forces, when brought to their limit, find rest in quiet symmetry. And in that symmetry, the universe breathes again. In the quiet theater of the cosmos, there comes a moment when gravity ceases to hold back. A star, once alive with light, exhausts the last of its fuel. The pressure that once balanced its weight fades like a dying breath, and in that instant, gravity wins. The core of the star collapses inward, faster than any sound, faster than any thought, folding upon itself until it becomes something so dense, so absolute, that not even light can escape. A black hole is born. To imagine such a thing is to imagine silence beyond comprehension. A black hole has no surface, no texture, no light. It is defined not by what it is, but by what it hides. Around it lies a boundary called the event horizon, the threshold between the visible and the invisible. Cross it, and you will never return. From outside, nothing escapes its gravity. Inside, the very fabric of space curves inward endlessly. Yet for all its mystery, the black hole is not chaos. It is precision. It is the clean geometry of inevitability. If you could stand at a distance and watch the formation of this object, you would see a star collapsing into darkness, its light squeezed into an ever smaller region. To an outside observer, time would seem to slow as the star neared the event horizon. The final moment of collapse would appear frozen, stretched across eternity. This is not illusion, but consequence. Gravity bends time as surely as it bends space. Near the horizon, seconds and centuries lose distinction. The deeper the gravity, the slower the clock. The idea of time slowing in gravity is not just a theory, but a truth proven by observation. Atomic clocks placed higher above Earth's surface tick slightly faster than those below. The difference is tiny but measurable. In the extreme field of a black hole, that difference grows infinite. To the falling observer, time flows normally. To the distant one, it stops. This strange division of perspective is the essence of relativity. There is no single universal time. There is only the rhythm of each frame, woven by gravity's hand. To the one who falls, the experience is different. Imagine yourself drifting toward the black hole, feet first, unafraid. The sky behind you glows with distorted light. The stars above seem to curve around an invisible hole. As you approach, your sense of motion dissolves. You are not moving through space. Space is moving through you. It flows like a river into the horizon. You are being carried gently, inevitably inward. At first, you feel nothing unusual. The pull of gravity is strong but even. Then, as you draw closer, you notice the difference. Your feet, closer to the center, are pulled more strongly than your head. The gradient sharpens. The same tidal force that once lifted oceans now stretches you thin. The force grows exponentially as distance shrinks. At a certain point, the difference in gravity across your body exceeds what molecules can bear. You begin to elongate. Physicists call this spaghettification, a word that sounds playful but hides terror. It is the body's final interaction with the universe, to be translated into a thread of atoms, drawn into the fabric of space. Yet even this is not violence in the cosmic sense. It is simply geometry taken to its limit. The formula that describes the tidal force is simple, elegant, and unyielding. It shows that the smaller the black hole, the greater the stretching near its horizon. A stellar black hole, only a few kilometers wide, would destroy you long before you reach the edge. The pull changes so rapidly that even steel would shatter. But a supermassive black hole, millions or billions of times the sun's mass, is different. Its event horizon lies so far from its center that the gradient becomes soft. You could cross it unharmed, unaware that you had passed the threshold of no return. This paradox reveals a truth both physical and spiritual. The larger the black hole, the gentler its edge. The more immense its gravity, the calmer its horizon. Power, in its purest form, becomes stillness. The small are violent because their change is sharp. The great are peaceful because their influence is wide. It is a lesson the universe repeats endlessly. Magnitude breeds serenity. Let us look at what defines this horizon more closely. The Schwarzschild radius, the simple equation 2gm over c squared, gives the distance from the center at which escape becomes impossible. For the sun, if compressed into such a state, that radius would be about 3 kilometers. For Earth, less than a centimeter. For a black hole with billions of solar masses, the horizon spans billions of kilometers. At these scales, the curvature of space becomes vast but gentle. The edge is not a wall. It is a boundary of perspective. Crossing it, nothing changes locally. There is no shock, no sudden light, no resistance. The horizon is not a surface, but a region where space itself falls faster than light can climb. From within, all paths lead inward. Outward motion is no longer defined, yet for the falling traveler, there is no sensation of entry. The universe around seems to continue as before until time itself slows to a breath and then to stillness. It is difficult for the mind to grasp what lies beyond this horizon. Inside, distance and direction lose their familiar meaning. The singularity at the center is not a place in space, but a place in time, the inevitable future of all who cross the threshold. Everything that enters moves toward that future as surely as seconds move toward the next minute. The singularity is the end of motion, where density and curvature become infinite, and the known laws of physics cease to speak. Yet even this silence is not meaningless. It is the boundary where understanding gives way to wonder. Physicists sometimes imagine what might happen to information that falls into a black hole. Does it vanish, or is it preserved somehow in the curvature of the horizon? Stephen Hawking showed that black holes are not completely black. They emit faint radiation, born from quantum fluctuations at the edge. Over immense timescales, this radiation carries energy away, shrinking the black hole until it evaporates entirely. Even the darkest gravity must one day fade. Nothing, it seems, escapes impermanence. If we could witness such evaporation, it would unfold slower than any human measure. A black hole with the mass of the sun would take longer than the age of the universe to vanish. A supermassive one would outlive galaxies. When it finally releases its last whisper of heat, it will leave behind only curvature flattened back to calmness. In that final breath, all that once fell into it will be returned to space in a new form. The universe does not destroy, it recycles. To reflect on this is to feel the strange compassion of gravity. It pulls relentlessly, yet it also unites. It is the reason stars form, the reason planets orbit, the reason time itself has direction. Even in its most extreme expression, gravity remains a law of connection. The black hole is not an end, but a continuation of this bond, a place where everything merges completely. The word horizon suggests distance, but in truth, it is intimacy. It is the point where the universe touches itself, where all separation dissolves. For the falling traveler, crossing the horizon is not death, but absorption. They become part of the geometry that sustains the cosmos. From the outside, it looks like disappearance. From the inside, it feels like completion. There is something profoundly human in this. Every life has horizons, moments beyond which we cannot return, experiences that mark irreversible change. The fear of crossing them mirrors the fear of the black hole, the fear of losing identity, of vanishing into something greater. But as the physics shows, the crossing itself is gentle. The transition from the known to the unknown happens quietly. What lies beyond may be unimaginable, but it is not necessarily cruel. Consider again the small black hole, fierce and sharp. It devours with violence because its curvature changes abruptly. The larger one, vast and slow, allows you to drift across in peace. Perhaps consciousness, too, grows softer with expansion. The more it holds, the less it resists. The more massive the understanding, the gentler its boundaries. To know everything would be to let go entirely, to fall into stillness without fear. In this way, the black hole becomes a metaphor for transcendence. It is both limit and liberation. Everything that enters loses its individuality, but gains unity. Matter becomes motion. Motion becomes curvature. Curvature becomes silence. The darkness is not absence, but the pure presence of the unknown. To fall into it is to surrender the illusion of separation. Astronomers once feared black holes as cosmic destroyers. Now we know they are also creators. At the centers of galaxies, supermassive black holes anchor the orbits of billions of stars. Their gravity shapes the spiral arms, stabilizing the luminous disks we see in the night sky. Without them, galaxies might never have formed as they did. Even destruction has a role in structure. The void is an architect. So the next time you look up at the Milky Way and see its luminous band, remember that at its heart lies a darkness. That darkness is not the opposite of light, but its origin and balance. The stars orbit because of it. The galaxy breathes because of it. Every spark in the sky owes its position to something unseen. This is the paradox of existence, that what we cannot observe defines what we can. At the end of our thought experiment, imagine you have crossed the event horizon. There is no sound, no light, no sense of falling. The universe has folded you into itself. Time stretches until moments no longer separate. You are neither alive nor dead, neither moving nor still. You are part of the curve that once drew you in. The fear of annihilation fades, replaced by the awareness that everything changes form, but nothing truly disappears. Outside, a distant observer might still see you frozen on the horizon, forever falling, but never reaching the end. To them, you have become part of the boundary, a shimmer of red light fading into darkness. To yourself, you are already beyond, at peace, in a place where direction has no meaning. Both perspectives are true. Both are parts of the same reality, separated only by position. And perhaps that is the quietest revelation of all, that reality itself is relative. What seems like an end from one view is continuity from another. The black hole, far from being the universe's abyss, is its mirror. It shows us that endings are illusions shaped by perspective. On the far side of every horizon, there is stillness waiting, not as punishment, but as completion. So let the image settle. The star that was once blazing, now condensed to silence. Around it, the space of creation curves inward, not out of malice, but necessity. It holds what it has gathered, transforming motion into memory. Somewhere beyond the reach of time, the last particles of light spiral inward, joining the quiet at the center. And there, in the pure geometry of gravity, the universe rests in itself. In that rest, perhaps, is the truest peace. Not absence, but unity. Not death, but the merging of all things into one infinite calm. The black hole is not a monster. It is the sigh of the cosmos after a long, brilliant life. It is the pause between breaths, the silence that makes the music of existence possible. And when we finally understand it, we may see that falling into the dark is not falling away, but falling home. Far away in the quiet depth of the universe, beyond the spiral arms of our galaxy, there exists a giant so vast that numbers begin to lose their meaning. It sits at the heart of another galaxy called Messier 87, an ancient elliptical world of light and dust, 55 million light years from where you sit now. At its center is a black hole so large that it contains the mass of 6.5 billion suns. Its name is M87, and though it is invisible to the eye, it is surrounded by a halo of light that glows in radio waves, the echo of matter spiraling toward its dark heart. This is not merely an object. It is a cathedral of gravity, the calmest and most powerful being we have ever found. In 2019, scientists captured its image for the first time, not a photograph of the hole itself, but of the light that bends around it, forming a ring of fire against the dark. That ring is a whisper of what cannot be seen. It marks the place where light circles forever, trapped between falling in and escaping out. To look at that image is to glimpse eternity. It shows a perfect balance between motion and stillness, a boundary drawn not by walls but by geometry. Inside, time curves upon itself. Outside, the galaxy continues to breathe. The paradox of M87 ticks is profound. For all its mass, its pull at the horizon is gentle. If you were to drift toward it, you would cross its event horizon without feeling a single tug. The gradient of gravity, the difference between your head and your feet, would be so small that you might not even notice the passage. You could glide across the boundary where light itself hesitates, unaware that you had entered a region from which nothing escapes. You would fall without pain, without noise, without resistance. This is what makes supermassive black holes safe in a quiet and absolute way. The reason lies in scale. The same formula that predicts destruction near small black holes predicts safety near large ones. Tidal forces, the differences in gravitational pull, grow weaker as mass increases. The equation shows this clearly. The tidal acceleration at the horizon scales inversely with the square of the black hole's mass. Double the mass, and the tidal force becomes 4 times smaller. Multiply the mass by 1,000,000, and the force becomes 1,000,000,000,000 times softer. Immensity breeds gentleness. If a black hole with the mass of our sun would tear a body apart long before it reached the horizon, a black hole like M87T would cradle that same body across its edge unharmed. The curvature is broad, the gradient smooth. The body, instead of being shredded, would drift whole. Space bends so gradually that even molecules would remain intact. The greatest danger becomes the most serene experience imaginable. This is the quiet irony of gravity. The smaller the object, the sharper its touch. The larger the being, the softer its hand. It is a truth that feels almost spiritual. Greatness, whether in stars or in consciousness, brings calm. When a mind expands to hold many things, it no longer clings to each of them. When a black hole grows to hold millions of suns, it no longer tears, it gathers. It becomes a sanctuary of stillness in the midst of cosmic motion. Around M87T, light bends gracefully. Jets of plasma shoot from its poles, streams of energy moving at nearly the speed of light, reaching across thousands of light years. Yet at its center, there is no chaos, only quiet. The most active region in the galaxy arises from a heart that does not move. Imagine approaching it. From afar, the galaxy looks like a golden mist. As you draw closer, the light fades, replaced by a smooth darkness that seems to absorb sound. The stars grow sparse. Space feels heavier. You are falling, but the fall feels like floating. The horizon ahead is vast, stretching across billions of kilometers. You pass through it gently, unaware that the universe outside can no longer see you. Inside, there is only silence and the curved flow of space-time. You would expect terror, but what you feel instead is peace. There is no sudden pull, no tearing, no pain. The vastness of the whole makes its transition seamless. The difference in gravity across your body is smaller than what you felt standing on Earth. The tidal force at the horizon is less than the weight of a falling feather. You are entering the most powerful object in existence, and yet it receives you with perfect stillness. It is strange to think that the same laws of physics that once warned us of annihilation now reveal gentleness. When scientists first imagined black holes, they were seen as monsters, cosmic traps devouring everything in their path. But the truth, as it often is subtler and more beautiful. These giants are not destroyers, but caretakers. They govern the dance of galaxies, anchoring billions of stars in place. Without them, the galaxies would drift apart. Their darkness gives structure to light. Their gravity gives coherence to creation. The universe, it seems, knows balance. Where there is motion, there must be stillness. Where there is expansion, there must be focus. The black hole provides that focus. It is the counterpoint to the stars, the silent listener in the symphony of the cosmos. Around M8017, the galaxy orbits like a slow spiral of fireflies around a candle's flame. Each star follows a path written by the gravity of the unseen. And yet, the unseen is not absence. It is presence so complete that it no longer needs to announce itself. Let us return to the equation for the Schwarzschild radius, r equals 2gm divided by c squared. In it, mass and geometry meet. The larger the mass, the greater the radius, the gentler the gradient. When you substitute the mass of M87 Col, the horizon becomes enormous, nearly the size of our solar system. The space there is curved, yes, but gently, like the slope of a hill stretched over infinity. To fall across it is not to plunge down a cliff, but to stroll down a long, soft valley. In this vastness lies a metaphor for understanding. The small mind sees division, sharpness, borders. The great mind sees connection. It stretches its awareness so wide that contrasts blur into continuity. A supermassive black hole behaves the same way. Its power is so immense that it dissolves the sharpness of its own pull. It becomes vast enough to be kind. If you could pause time and look around from near the horizon, you would see light bending in circles. Some rays would loop once and escape. Others would loop twice and vanish. You would see the universe repeated in rings, reflections of the sky curved around the darkness. In every direction, the same image of stars would shimmer, bent by gravity's lens. To witness this would be to witness beauty shaped by physics alone, the pure art of geometry. And yet, for all its grace, M87 remains a mystery. Inside its horizon, all equations lose meaning. We can describe what happens outside. We can predict the path of light, but beyond that edge, knowledge stops. This stopping is not failure, it is humility. It reminds us that even in the age of equations and machines, there are still places we cannot reach. There must always be mystery, for mystery is the space that gives meaning to knowing. In this way, the black hole becomes not just a physical object, but a teacher. It teaches that strength and softness are not opposites, that boundaries are illusions, that the greatest power exists in silence. The supermassive black hole does not rage, it holds. It does not destroy, it transforms. Everything that falls into it adds to its mass, makes it grow, and in growing, it becomes gentler still. It is the perfect metaphor for wisdom. The more it absorbs, the less it resists. From our distant perspective, the light around M87 kegs is ancient. It has traveled millions of years to reach us, carrying the story of its origin. When you see that orange ring in the famous image, you are seeing the past. The photons that touch your eyes tonight left that galaxy before humanity existed. They have crossed the void to bring you a message written in curvature, that even in darkness there is symmetry. Even in silence there is song. The jet that shoots from M87K is another kind of poetry. It emerges not from within the horizon, but from the space just outside, where magnetic fields twist and accelerate particles to near the speed of light. Those particles create a beam that stretches thousands of light years into intergalactic space, glowing in X-rays and radio waves. It is as if the black hole breathes, exhaling energy it can never keep. What appears as an abyss becomes a source. Even the void gives back. Such paradoxes are the nature of existence itself. The more we learn, the more we see that opposites are illusions. The black hole that consumes also creates. The gravity that confines also connects. The darkness we fear is the framework that makes light possible. Without the quiet pull of these invisible centers, the universe would be chaos, expanding without form, scattering into emptiness. The black hole provides focus, a gravitational heart that allows galaxies to live, and perhaps that is what the universe whispers to us through these giants. That scale changes everything, that what looks terrifying from a distance may be peaceful up close, that growth leads not to greater destruction, but to greater calm. A supermassive black hole is gravity matured, patience made visible. It has seen countless stars fall into it, countless worlds vanish, and yet it remains composed. Nothing stirs its surface because it has no surface. It accepts all that comes without reaction. If one day humanity travels far enough to approach such a horizon, the experience will not be one of fear, but of reverence. To look upon M87 up close would be to confront the stillness that underlies all motion. You would see light spiral around it in slow fire, the galaxy reflected upon itself, time bending into circles. You would realize that the universe is not violent, but vast, not cruel, but consistent. The black hole would not swallow you in anger. It would hold you as part of its continuation, as gravity has always held all things. When you step back from the equations and look with the eyes of wonder, the lesson becomes clear. The universe is not built on destruction, but on transformation. Stars collapse, but their collapse gives rise to new order. Galaxies orbit darkness, but that darkness grants them shape. Even the supermassive black holes that seem to mark the end of matter are instead the centers of its renewal. Through them, energy and structure cycle endlessly. So when we speak of black holes as safe, we do not mean safe in a human sense. We mean that they are true to their nature. They do not deceive or deviate. They are the pure expression of the law that binds everything. Gravity, the quiet pull toward unity. To fall into such a being is to return to the simplest truth of the cosmos, that all separations are temporary, and that everything that was scattered will one day come together again. Perhaps then, the universe is teaching us something through these massive hearts of darkness, that to grow vast is to grow gentle, that to hold everything is to harm nothing, that peace is not found in escaping gravity, but in understanding it. The black hole at the center of M87 does not fight its role. It fulfills it. It does not move, yet everything moves because of it. It is stillness that sustains motion, emptiness that holds form. And if you listen closely, through the static of cosmic background, through the hum of galaxies and the whisper of expanding space, you might hear it. Not a sound, but a truth. That the universe is not racing toward oblivion, but breathing toward balance. Each black hole is a pause in that breath, a heartbeat so slow it feels eternal. The stars drift around it, the galaxies turn, and somewhere in that grand rotation, you too are moving, caught in the same geometry. drawn by the same quiet force. The darkness at the center is not something to fear, but something to trust. It holds the pattern together. It keeps the stars from scattering into chaos. It reminds you that even at the edge of everything, the universe remains gentle. Across the immensity of space, every story ends the same way, quietly folding back into the dark that began it. The stars that once burned with brilliance fade. The galaxies that once shimmered across the night grow dim. Even the black holes, those mighty hearts of gravity, slowly exhale their energy through faint radiation and drift towards stillness. Everything that rises returns. Everything that shines eventually rests. The universe breathes out, and its exhale lasts forever. To think of endings is to think of balance. In the cosmic rhythm, nothing is lost, only changed. The matter that once formed a star becomes dust. The dust becomes worlds. The worlds become oceans and people. And those people look back at the sky and wonder where it all came from. We are the question the universe asks itself. We are its memory made conscious. And when we gaze into the dark, we are not looking at emptiness, but at origin. If you were to travel far enough through light years of silence, you would find that every galaxy hides a black hole at its center. These are not monsters waiting to consume, but anchors that hold creation in place. Around them, the stars orbit like beads on a string. Their pull shapes the balance of everything that shines. Without that dark gravity, there would be no galaxies, no spiral arms, no place for stars to gather. What we call darkness is, in truth, structure. It is the invisible order behind all motion. At the scale of existence, safety does not mean survival, it means harmony. A supermassive black hole is safe not because it spares you, but because it fulfills its purpose perfectly. It keeps the galaxy whole. It allows light to circle, matter to gather, energy to flow. It is not the enemy of creation, but its quiet twin. The universe does not separate light from darkness as we do. It treats them as partners in the same dance. In that realization, fear softens. We begin to see that the black hole's pull is no different from the pull of time itself. Both draw everything forward. Both lead toward transformation. The fall is not a punishment, but a return. The stars fall. The light bends, the galaxies drift inward, and one day, even the atoms of our bodies will follow. Yet this fall is peaceful, for it is simply the continuation of what has always been happening. Imagine standing on the edge of such a horizon, watching the last light curve around it. The air would not tremble. The space would not roar. There would be no explosion, no sound. Only a calm deepening, as if the universe were holding its breath. You would see the glow of matter spiraling inward, forming a golden ring of fire. Beyond that, only blackness, smooth and perfect. It would not feel like death. It would feel like the closing of eyes at the end of a long day. The question that follows is natural. If everything falls inward, where does it go? What lies beyond the horizon? Beyond the silence? Physics answers with equations, but equations cannot feel. They tell us that space and time themselves bend inward, that beyond the event horizon lies the singularity, a place where all directions point toward the same end. But perhaps it is not an end at all. Perhaps it is a seed, a beginning folded within an ending, waiting to open again in another universe. Some theories suggest that every black hole might birth a new cosmos inside, each collapse an act of creation turned inward. If that is true, then the universe is infinite in both directions, forever creating itself from the ashes of its own collapse. Even if this is only speculation, the idea carries a quiet wisdom. The universe wastes nothing. The energy of a dying star becomes the gravity of a black hole. The death of that black hole may one day feed another birth. The cycle repeats across time beyond imagining. Creation and destruction are not opposites, but reflections. To destroy is to make room for something new. To collapse is to begin again. In our small human lives, we mirror this cosmic pattern. We rise, we shine, we fade. Our bodies are born from ancient stars, our breath recycled from forgotten worlds. The carbon in our blood, the calcium in our bones, the iron in our hearts, all were forged in the cores of long-dead suns. We are the descendants of collapse, the living dust of supernovae. Every thought we have is made possible by matter that once burned in the depths of a star. To remember this is to remember that we are never separate from the universe. We are its continuation in consciousness. So when we speak of black holes, we are also speaking of ourselves. We are speaking of the tension between gravity and light, between holding on and letting go. Each of us carries horizons within us, boundaries we cannot cross back over, changes we cannot undo. And yet each crossing makes us more complete. Growth requires surrender. Understanding requires descent. The beauty of science is that it teaches humility. It reminds us how small we are, yet how connected. When astronomers captured the first image of M87A, it was not just a triumph of technology, it was a moment of collective wonder. Thousands of people across the planet worked together to see the unseeable. That orange ring, glowing softly in the dark, is a testament to the unity of curiosity. It shows that even in a vast and cold universe, we are capable of reaching into the unknown together. To look at that image is to feel awe, but also peace. The black hole does not chase or devour. It simply waits, patient and unmoving. Around it, light continues to orbit, forming patterns of quiet repetition. The universe is not a story of chaos, but of balance, written in light and shadow. The black hole's calm is the calm of deep understanding. It has nothing left to prove. If we were to drift across its horizon, our final moments would not be pain, but transition. We would pass beyond the point of return, but not into nothingness. We would merge with space itself, becoming part of the same geometry that holds the galaxies in their spiral. In that sense, every fall is a return to belonging. Perhaps this is why black holes hold such fascination for us. They are mirrors of surrender. They remind us that there is peace in letting go. They teach us that even the end of everything can be soft, that power and calm can coexist. The most massive object in the universe is also the most silent. The darkest region of space is also the most ordered. What we fear most is also what completes the cycle of creation. If you listen deeply to this truth, you might begin to feel something gentle inside you, a recognition that the universe is not indifferent but patient. It does not rush its endings. It allows each transformation to unfold in its own time. The stars take billions of years to die, and their ashes take billions more to form new stars. There is no haste, no urgency, no tragedy, only continuity. We are the fleeting thoughts of an infinite mind, brief but essential. The next time you step outside on a clear night, look at the sky with this in mind. Each point of light is a story in progress. Some are newborn stars just beginning to shine. Others are already gone, their light still traveling toward you through the quiet ocean of space. Every photon is a message from the past, carrying the memory of creation. You are seeing time stretched across distance, the universe writing poetry with light. Somewhere within that darkness, the black holes wait. They are not lurking, but listening. They are the silent witnesses of all things, keeping the balance between light and void. Their gravity reminds us that even emptiness has purpose, even silence has depth. The stars orbit them not in fear, but in trust. They know that without that central darkness, they would scatter into nothing. The universe holds together because of what it cannot see. As we reach the end of this long drift through thought and space, let the image settle. A galaxy spinning gently, its heart a ring of fire around an invisible center. Everything that exists moves in harmony with it, from the smallest atom to the largest cluster of stars. The same laws that bend light around the black hole also shape your heartbeat, your breath, your dreams. You are made of the same symmetry that holds the cosmos together, and maybe that is the deepest meaning of all. The black hole, the star, the human, all are expressions of one principle: the return to unity. Gravity is the universe remembering itself. When we fall into darkness, we do not vanish. We become part of the whole again. The horizon is not an end, but a bridge. What lies beyond it is not nothingness, but everything combined. So rest in that understanding. Let it soften the edges of your thoughts. Let it remind you that endings are natural, that surrender is not defeat. Even the universe, with all its brilliance, eventually yields to its own rhythm. There is peace in the cycle. There is beauty in the return. If you have journeyed with me through this quiet exploration of gravity and time, I invite you to carry its stillness with you. Let the night sky remind you that you are part of something vast and kind. Each star you see is held by invisible threads of balance, and those same threads hold you too. And if this drifting through science and silence has brought you a sense of calm, I invite you to stay with us, to keep wandering through the gentle mysteries of existence. Subscribe to the Sleepy Science Drift, and together we will continue to breathe with the cosmos, to listen to its quiet pulse, to let wonder lead us toward rest. The stars drift slowly, the galaxy breathes, the universe hums with patience, and somewhere within that hum, you find yourself at peace.